In this video, we're going to talk about 10 things that you should know before taking an algebra course. So one of the first things that you want to be able to do is you need to know how to calculate the slope of a line given 2 points. And let's go over an example. Let's say the first point is -2 comma -3. And the second point, we're going to say it's 6 comma 9. What is the slope between these 2 points? Now there is a formula that we could use to find the answer. The slope indicated by the letter m is equal to y2 minus y1 divided by x2 minus x1. So the first number is the x coordinate, the second number is the y coordinate. So this is the first point, so let's call it x1, y1. And this is the second point, so it's going to be x2 and y2. Now we can see that y2 is 9, y1 is -3. x2 is 6, x1 is -2. Now what is 9 minus -3? Whenever you have two negative signs next to each other, it's equivalent to a positive sign. A negative times a negative is a positive number. So 9 minus -3 is the same as 9 plus 3, which is 12. And 6 minus -2, that's the same as 6 plus 2, which is 8. Now how can we reduce this fraction? Well, 12 is the same as 4 times 3. 8 is 4 times 2. And so we could cancel the 4, leaving behind 3 over 2. Therefore, this is the answer. So that's the slope between these 2 points. It's 3 over 2. Now the second thing that you need to know how to do is graph and linear equations. So let's consider this example. Y is equal to 3x minus 2. How can we graph this particular equation? Well, the first thing we need to recognize is that this equation is in slope-intercept form. That is, it's in y equals mx plus b form. M is the slope, which is 3, and b is the y-intercept, which is -2. So a y-intercept of -2 corresponds to the point 0, -2. It's basically where the graph touches the y-axis. So the x-axis is horizontal, the y-axis is vertical. So let's go ahead and put some marks on the graph. And then we're going to plot the y-intercept. So it's at -2 on the y-axis. And then we're going to use the slope to get the second point. So the slope m is basically the ratio of rise over run. So we have a slope of 3, which is the same as 3 over 1. So what we're going to do is, from the first point, we're going to rise 3 units, and we're going to run 1 unit to the right. So that should take us to the point 1 comma 1. And then we're going to rise 3 units, and then travel 1 unit to the right. And so that's going to take us to the point 4 comma 1. And then draw a straight line that connects the points together. And so that's a rough sketch of the graph that corresponds to this equation. Now sometimes you may need to graph a linear equation that is not in slope-intercept form. For instance, let's say if we're given this equation, 2x minus 3y is equal to 6. What can we do to graph this equation? In this case, what you want to do is find the x-intercept and the y-intercept. To find the x-intercept, replace y with 0. -3 times 0 is 0, so basically this disappears. and then you're left with 2x is equal to 6, and so you need to solve for x. So x is going to be 3. So that is the x-intercept, which means that we have the point 3, 0, because y was 0. Now to find the y-intercept, replace x with 0, and then calculate the value for y. So 2 times 0 is 0, so we're left with negative 3y is equal to 6. And then let's divide both sides by negative 3. So 6 divided by negative 3 is negative 2. Thus the y-intercept is 0, negative 2. So now all we need to do is plot those 2 points, and then we can just graph it. So let's plot the y-intercept first. And here it is, 0, negative 2. And now let's plot the x-intercept, which is 3, 0. And then connect those 2 points with a line. And I missed it. So let's do that again. And so that's another rough sketch of the graph that corresponds to this equation. Number 3, write in linear equations. So that's another skill that it's helpful to know if you're going to take algebra. So let's say if we're given a slope of a line, which is, let's say 3, and we have the point 2, 5. How can we write a linear equation given this information? Now what I like to do is write the linear equation using this formula, the point-slope formula, because we already have the slope, which is 3, and we have a point. So 2 is going to be x1, 5 is y1. Now let's plug in the information that we have. So let's replace y1 with 5, m with 3, and x1 with 2. So this is the equation in point-slope form. Now sometimes you may need to convert it to slope-intercept form, y equals mx plus b. And all you need to do is get y by itself. So let's go ahead and do that. The first thing we need to do is distribute the 3. So we have 3 times x, and then 3 times negative 2, which is negative 6. The last thing we need to do is add 5 to both sides. And so negative 6 plus 5 is negative 1. Thus, this is the answer in slope-intercept form, y equals mx plus b. Now, there's another form that you need to be familiar with, and it's called standard form, ax plus by equals c. So you can also represent a linear equation in that form too. Now, let's talk about parallel lines and perpendicular lines. Parallel lines never intersect. They have the same slope. So let's say that the slope of the first line is 2. The slope of the second line will also be 2. Now for perpendicular lines, it's a little different. So let's say this line has a slope of 3/4. A line perpendicular to it will intersect the first line at a 90-degree angle. Now, what is the slope of the second line? How can we find the answer? You can find it based on the first line. What you need to do is flip the fraction and change the sign. So the slope here is positive 3/4, and now it's going to be negative 4/3. And so that's how you could find the slope of a perpendicular line. Now, it's important to understand that a horizontal line has a slope of 0. A line that rises at a 45-degree angle has a slope of 1. And this is about a slope of 2. This would be a slope of approximately 1/2. Now, if the line is going down below the horizontal line, the slope will be negative. So this would be a slope of -1. That's a slope of approximately -2. And this would be -1/2. If the line is vertical, the slope is undefined. Because if you have a number over 0, it's undefined. So anytime you have a vertical line, you can't really put a number to the slope. So just keep that in mind. Now, a typical question that you might see in an algebra course dealing with perpendicular lines might go as follows. So let's say if you're given this equation, y is equal to -3/2x plus 4. And let's say you're given a point 2, 1. So write the equation of a line that is perpendicular to this line, but that passes through the point 2, 1. And let's write the equation in slope-intercept form. So we have the point, we have our x1 and our y1 value. The only thing we need is the slope of the second line. Now we have the slope of the first line. This is already in slope-intercept form. And the slope is the number in front of x. So it's -3/2. We need to find the slope of the line that's perpendicular to the first line. So let's call this m2. So first we need to flip the fraction. So instead of being 3/2, it's going to be 2/3. And then we need to change the sign from being negative to positive. So now we have the slope and the point that goes with it. Now we could use the point slope formula to write the equation of the line. So we can see that y1 is 1, and m is 2/3, and x1 is 2. So now let's get the answer in slope-intercept form. So we need to get the y variable by itself on the left side. Let's begin by distributing 2/3 to x and -2. So this is going to be 2/3x, and then 2/3 times 2, which is the same as 2/1. So we have 2 times 2, which is 4, and then 3 times 1, which is 3. So now let's get rid of this. Now let's add 1 to both sides. So how do we add -4/3 and 1? To add a fraction to a whole number, you need to get common denominators. 1 is the same as 3 divided by 3. 3 divided by 3 is 1. So now that we have the same denominator, we can add the numerators of the two fractions. So -4 plus 3 is -1. So the answer is going to be 2/3x minus 1/3. And so this is the equation of the line that's perpendicular to the first line. It has a slope of 2/3 and a y-intercept of -1/3. You can also represent the y-intercept as a coordinate point. You can say it's 0, -1/3. And so that's it for that problem. Now the fifth area that we want to talk about is solving linear equations. And we're going to go over some basic examples, nothing too complicated. For instance, let's say if 5x is equal to 20. What is the value of x? And that really is the purpose of solving an equation. Your goal is to find the value of the variable. And the variable is basically a number for which you don't know the value at the present, but you need to find it. So how can we find the value of x? what you need to do is get the variable on one side of the equation by itself. So you need to get rid of the 5 on the left side. Right now, the 5 is multiplied to the x variable. And so you need to basically undo that, so to speak. The opposite of multiplication is division. So we need to divide both sides by 5. 5 divided by 5 is 1. So you get 1x, which is the same as x. On the right side, it's 20 divided by 5, which is 4. And so x has a value of 4. And it makes sense because 5 times 4 is 20. So thus x is equal to 4. Now what if you have an equation that looks like this? A number divided by 3 is equal to 8. What is the value of that number? Intuitively, you know that 24 divided by 3 is 8. So x is 24. But what process do we need to take to get the answer? Right now, x is divided by 3. The opposite of division is multiplication. So you want to multiply both sides by 3. So this is the same as 3 over 1. And so 3 times x is 3x. And 1 times 3 is 3. Or, if you prefer, you can simply just cancel the 3's. And so you just have x on the left side. On the right side, you have 8 times 3, which is 24. And so that's the answer. Now let's try a problem that has multiple steps. So let's say that 3x plus 7 is equal to 22. What is the value of x? So what should we do? Should we try to get rid of the 7 on the left side or the 3 first? I recommend getting rid of the 7, not the 3, in the first step. Because if you try to divide by 3, you need to divide every number by 3. And 3 doesn't go into 7 nicely. So it's easier to subtract both sides by 7. Whatever you do to the left side, you must also do to the right side, in order that the value of both sides of the equation remain the same. So 22 minus 7 is 15. And this you could bring it down. Now the last step is to separate the 3 from the x by division. And so 15 divided by 3 is 5. And that's the answer. And of course, you can check your work by plugging 5 into the original equation. So here is the original equation, and we said that x is equal to 5. So let's substitute x with 5. 3 times 5 is 15. 15 plus 7 is 22. So the equation is balanced, which means that this is the right answer. Now let's try a more complicated example with parentheses and variables on both sides of the equation. So go ahead and calculate the value of x in this example. Now, if you have parentheses, the first thing you want to do is to get rid of them. And you could do so by distribution. So let's distribute 3 to 2x and to negative 5. 3 times 2x is 6x, and 3 times negative 5 is negative 15. Now let's do the same on the right side. 5 times 2x is 10x, and then 5 times negative 3 is negative 15. Now, let's add like terms. So these two are similar. Negative 15 plus 4, that's negative 11. And then negative 15 plus 6 is negative 9. So now what we need to do is move all of the x variables on one side of the equation and all of the y variables, not the y variables, but all of the constants on the other side of the equation. So let's subtract 6x from both sides. You can subtract 10x from both sides, and it can work as well. You can get the x variable on the left side by itself or on the right side by itself. Either way, you can still get the right answer. But now let's add 9 to both sides. So all of the x variables will disappear on the left side, and all of the constants will disappear on the right side. Negative 11 plus 9 is negative 2, and 10x minus 6x is 4x. So now, let's divide both sides by 4. So we have negative 2 over 4 is equal to x. So we only have the x variable on one side of the equation and all of the constants on the other side. Now the last thing that we need to do is reduce our answer. So right now we have this answer. And since both numbers are even, we can divide by 2. Negative 2 divided by 2 is negative 1, and 4 divided by 2 is 2. So our final answer is that x is equal to negative 1/2. And that's it for that example. Now let's go over one more example. So let's say if you have two fractions separated by an equal sign. What can you do to calculate the value of x in this example? Whenever you have two fractions separated by an equal sign, you can cross multiply. 4 times 5 is 20. And 2 times x plus 6 is 2 times x plus 6. Now at this point, we could distribute the 2 to the x plus 6, or we could divide both sides by 2. Both ways will lead to the same answer, but I'm going to divide both sides by 2. So these will cancel. On the left, 20 divided by 2 is 10. And so we have 10 is equal to x plus 6. And now the last thing we need to do is subtract both sides by 6. So 10 minus 6 is 4. Thus, x is equal to 4. And so that's it for that problem. Now let's talk about solving and graphing linear inequalities. The first thing we should do is graph linear inequalities. Let's go over a few basic examples. So how can we graph this particular inequality? X is greater than 2 on a number line. So let's say this is 0, 1, 2, 3, 4, 5. So x is greater than 2. We need to represent that with an open circle. Let me use a different color. But because it's greater than, we need to shade towards the right side. And so that's how we can graph this inequality on a number line. If you wish to represent the solution using interval notation, you could say that x is greater than 2. That is, it's between 2 and infinity. Positive infinity extends all the way to the right. Negative infinity extends to the left. So these two mean the same thing. Now let's try another example. Let's say that x is equal to or greater than positive 3. So let's say this is 0, 1, 2, 3, and so forth. So the only difference here is that we're going to use a closed circle instead of an open circle. But because x is still greater than 3, we're going to shade towards the right. Now in interval notation, we're going to use a bracket to represent that 3 is included due to the closed circle. So it's still from 3 to infinity, but if 3 is included, use a bracket. For infinity, you should always use parentheses. Now let's say that x is less than negative 1. So here's negative 1. And it doesn't equal negative 1, so we're going to use an open circle. But because it's less than, we're going to shade towards the right. So in interval notation, looking at it from left to right, you can represent the answer as being negative infinity to negative 1. And so always use parentheses when you have an open circle. Now let's say if we wish to graph this one, x is less than or equal to negative 2. So this time we're going to shade to the left, but using a closed circle. And so in interval notation, it's from negative infinity to negative 2, but it includes negative 2 in the solution. And so that's how we can represent it. Now, in terms of graphing, the next thing you need to be familiar with is the and the or statements. So you can have something like this: x is less than 1 or x is equal to or greater than 4. In this case, to graph the solution, so here's 1, 2, 3, 4, and so forth. Let me redo that. Let's put 0 on this side. So x is less than 1. We're going to use an open circle. Or x is equal to or greater than 4. So we're going to shade to the right, starting with a closed circle. And so that's how we can graph these two inequalities on a number line. Now the solution in interval notation, it's going to be negative infinity to 1. So that's the first part. And then union, we're going to connect this to the second part, 4 to infinity. But it includes 4. So we need to use a bracket. Now let's try another one. So let's say that x is greater than or equal to negative 3, but less than 2. How would you graph that one on a number line? The first thing that we could see is that x is greater than or equal to negative 3. You can also read it as negative 3 is less than or equal to x. But you can take that portion and write it this way if it's easier to see it. So this means that we're going to have a closed circle at negative 3, and because x is greater than negative 3, we're going to shade to the right of negative 3. Now let's focus on this portion. So that tells us that x is less than 2. So we're going to have an open circle at 2, but because it's less than, we're going to shade to the left. So thus we need to shade between negative 3 and 2. Now, the answer is going to be from negative 3 to 2 in interval notation. So we have a bracket at negative 3 and a parentheses at 2. So that's how we could represent the solution using interval notation. And so that's it for that example. Now let's work on some examples where we're actually solving a linear equality. So let's start with a simple one. 5x minus 11 is greater than or equal to 9. So go ahead and solve it and then graph the solution on a number line. Now the way you solve an inequality is very similar to the way you solve an equation. You need to get the x variable by itself on one side of the inequality. So you can view this as if it was an equal sign. So let's add 11 to both sides. On the right side we have 9 plus 11, which is 20. Now let's divide both sides by 5. And so 20 divided by 5 is 4. So thus we have this answer. X is equal to or greater than 4. And so to graph the inequality, it's going to look like this. So we're going to have a closed circle shaded to the right. And to represent that in interval notation, it's 4 to infinity. Now go ahead and try this example. Negative 3 divided by 4 times x plus 5. And let's say that's greater than negative 1. What is the solution? Take a minute, pause the video, and see if you can find the answer. So let's begin by subtracting both sides by 5. And so negative 1 minus 5 is negative 6. Now what do we need to do at this point? How can we get x by itself on one side of the inequality? So we need to get rid of the fraction, negative 3 over 4. And what we could do is multiply both sides by the reciprocal of that fraction. And that is by negative 4 over 3. Because on the left side, the 4's will cancel, and the 3's will cancel, and the two negative signs will become positive. So we'll be left with x only on the left side. Now, what should you do every time you multiply or divide by a negative number when dealing with inequalities? Do you remember? Anytime you multiply or divide by a negative number, you need to change the direction of the inequality. You need to flip it. Now, on the right side, we have negative 6 times negative 4, which is 24, and 24 divided by 3 is 8. Or you could divide first, then multiply. Negative 6 divided by 3 is negative 2. Negative 2 times negative 4 is still positive 8. So the answer is that x is less than 8. So we're going to have an open circle shaded to the left. So as an inequality, we can write it using interval notation, we can write the solution as negative infinity to 8. And so that's it for that example. Now, for those of you who want more examples on any of the topics that you see here, check out the description section of this video, because I'm going to post a link to my new algebra video playlist. And you could find, in order, all of these topics that you might need more examples on. So feel free to take a look at that when you get a chance. Now let's move on to our next example, solving absolute value inequalities. So let's say we have this expression. The absolute value of 3x plus 4 is equal to 9. What is the value of x? Now, before we do this, it's important to understand the concept of the absolute value. The absolute value of positive 5 is 5. And the absolute value of negative 5 is still positive 5. So the absolute value expression takes whatever is inside of it and makes it a positive number. So if you start with a positive number, you will end with a positive number. But if you start with a negative number, it's going to convert it to a positive number. So let's apply that fact to this equation. So we have the absolute value of something that is equal to 9. So what is the value that needs to be on the inside? Well, there's two possibilities. To get positive 9, it should be equal to 9 or negative 9. So thus, to get the value of x, we can set 3x plus 4 equal to two potential values, 9 or negative 9, because they will give us the same output of positive 9. So whenever you're solving absolute value equations, you need to split it into two parts. So whatever is on the inside of the absolute value expression, you could set it equal to the positive version of that value, in this case positive 9, and the negative version of that value, so negative 9, giving you two possible answers. So now let's solve each equation. 9 minus 4 is 5. And then if we divide it by 3, we can see that one potential answer is 5 over 3. On the other side, we need to subtract by 4. Negative 9 minus 4 is negative 13. And so the other possible answer is negative 13 over 3. And so we have two answers for this example. Here's another example. 4 times the absolute value of 2x plus 3 minus 8 is equal to 36. What are the two possible values of x that will make this equation true? Now at this point, you don't want to break it up into two equations because you need to get the absolute value expression by itself first, which means you need to get rid of the 4 and the negative 8 on the left side. Anything outside of the absolute value expression, any numbers outside of it, you need to move it to the other side before you split it into two equations. So let's begin by adding 8 to both sides. 36 plus 8 is 44. Now the next thing we need to do is divide both sides by 4. 44 divided by 4 is 11. Now at this point, when you only have an absolute value expression on one side of the equation with no numbers outside of it, now you want to break it up into two equations. That is 2x plus 3 is equal to 11, and 2x plus 3 is equal to negative 11. You don't want to do that before this point. If you were to write two equations at the beginning, positive 36 and negative 36, you'll only get one of the two answers. So be careful with that. Now let's solve the first one. So let's subtract both sides by 3. And so 11 minus 3 is 8. And then if we divide both sides by 2, 8 divided by 2 is 4. So the first answer is x is equal to 4. Now for the second one, let's subtract both sides by 3. Negative 11 minus 3 is negative 14. And now let's divide both sides by 2. Negative 14 divided by 2 is negative 7. And so this is the second answer. So we have two possible answers. Now the next topic that we're going to review is solving quadratic equations by factoring. So let's say we have a trinomial that is an algebraic expression with 3 terms where the leading coefficient is 1. How can we factor this expression so as to calculate the value of x that will make this equation true? So what you need to do is focus on this number. You need to find two numbers that multiply to 15 but add to the middle coefficient of 8. So what two numbers multiply to 15 but add to 8? So this is 5 and 3. 5 times 3 is 15, 5 plus 3 is 8. And so to factor it, it's going to be x plus 5 times x plus 3. Now after you factor it, you want to separate it into two equations. You want to set each factor equal to 0. So we're going to set x plus 5 equal to 0 and x plus 3 equal to 0. So for the first equation, if we subtract both sides by 5, we can see that x will be equal to negative 5. And for the second one, if we subtract both sides by 3, x is equal to negative 3. And so that's a simple way in which you can solve a quadratic equation by factoring if the leading coefficient is 1. Now let's try another example. X squared plus 4x minus 21 is equal to 0. So based on a previous example, try this one. So what two numbers multiply to negative 21 but add to the middle coefficient of 4? Well, we know that 7 times 3 is 21. But for us to get negative 21, one of these numbers has to be positive and the other has to be negative. So we have two options, negative 7 and positive 3, or positive 7 and negative 3, both of which, when multiplied, will give us negative 21. However, positive 7 plus negative 3 will add to positive 4, and so we're going to use that. So we can factor the expression as x plus 7 times x minus 3. And so setting each factor equal to 0, we can now get the answer. So for the first one, x will be equal to negative 7, and for the second one, x will be equal to positive 3. And so those are the two answers for this problem. Now, what do you do if the leading coefficient is not 1? Let's say in this case, it's 6. How do you factor this expression? What should we do? What you need to do at this point is you need to multiply the leading coefficient by the constant term. 6 times negative 12 is negative 72. Then you need to find two numbers that multiply to negative 72, but that add to the middle coefficient of 1. So 72 is equal to 6 times 12. It's equal to 2 times 36. It's equal to 4 times 18, 8 times 9, but only 8 and 9 differ by 1. And so to make this work, we're going to have to use negative 8 and positive 9, because negative 8 plus 9 adds up to positive 1. Now this time we're going to do something different. What we're going to do is we are going to replace the 1x with 9x and negative 8x, because 9x minus 8x is still 1x, and so the value of the expression remains the same. Now at this point, now that we have 4 terms, we are going to factor by grouping. So in the first 2 terms, we're going to take out the GCF, the greatest common factor. The greatest common factor between 6 and 9 is 3. And between x squared and x, it's x. So we can take out a 3x from these 2 terms. Now, 6x squared divided by 3x is 2x. And 9x divided by 3x is 3. Now, let's do the same for the last 2 terms. Let's take out the GCF, which in this case is going to be negative 4. Negative 8x divided by negative 4 is positive 2x. Negative 12 divided by negative 4 is positive 3. Now, if you get 2 factors that are the same, that tells you you are on the right track. So what we're going to do now is we're going to factor the GCF of these 2 expressions, which is 2x plus 3. So if you take this entire expression divided by 2x plus 3, the 2x plus 3's will cancel and you'll get 3x. Likewise, if you take this and divide it by 2x plus 3, you'll be left with negative 4. So basically, what you need to do is write this once, and then everything outside of it, just put it inside the second parentheses. Now, let's make sure that our answer is correct. What we can do is we can FOIL this expression to see if it's going to give us the original expression. 2x times 3x is 6x squared. And then 2x times negative 4 is negative 8x. 3 times 3x rather is 9x. And 3 times negative 4 is negative 12. And as we can see, if we combine these two, negative 8x plus 9x, it's going to give us 1x. And so what we have so far is correct. Now what we're going to do is we're going to separate the two factors into two equations. So now let's calculate the value of x. So for the first one, we need to begin by subtracting both sides by 3. And so we're going to get 2x is equal to negative 3. And then we're going to divide both sides by 2. So x is negative 3 over 2. For the second one, we need to begin by adding 4 to both sides of the equation. So 3x is equal to 4. And then we'll divide both sides by 3. And so x is also equal to 4 over 3. And so those are the two possible answers. Now the next thing that we are going to do is we're going to talk about how to solve systems of equations. And so let's start with this example. Let's say that we have 2x plus 3y is equal to 18 and 3x minus 5y is equal to negative 11. So we have two equations and two variables. If there are three variables, you need three equations to solve it. How can we find the value of x and y in this example? Let's use the elimination method, also known as the addition method. Now you need to determine which variable you want to eliminate, x or y. And I'm going to pick y. Right now, if we add the two equations, the y variables won't cancel. So what I'm going to do is multiply the first equation by 5, so I can get 15y. And the second equation, I'm going to multiply that by 3. So everything in the first equation, I'm going to multiply by 5. So 2x times 5, that's going to be 10x. And then 3y times 5 is 15y. And 18 times 5. 10 times 5 is 50. 8 times 5 is 40. 50 plus 40 is 90. Now, 3x times 3, that's 9x. Negative 5y times 3 is negative 15y. And negative 11 times 3 is negative 33. Now let's add the two equations. If we do so, the y variables will cancel. Plus 15y with negative 15y adds up to 0. And so we're going to get 19x is equal to 90 minus 33. 90 minus 30 is 60, and 60 minus 3, that's going to be 57. Now, if we divide both sides by 19, 57 divided by 19 is 3. So x is equal to 3. Now, once we have that, we could use the original equation to get the value of y. So let's use this equation before we multiplied it by 5. So let's replace x with 3, and let's calculate the value of y. 2 times 3 is 6. And now let's subtract both sides by 6. 18 minus 6 is 12. Now, if we divide both sides by 3, 12 divided by 3 is 4. So y is equal to 4. So our answer is 3 comma 4, x comma y. To check the answer, what you could do is plug it back into both equations to see if you get the right answer. So let's start with the first equation. 2 times 3 plus 3 times 4. Let's see if that's equal to 18. 2 times 3 is 6, 3 times 4 is 12, and 6 plus 12 is 18. So that works. Now let's do the same for the second equation. Let's replace x with 3, and let's replace y with 4. 3 times 3 is 9, 5 times 4 is 20, and 9 minus 20 is negative 11. So that works as well, which means this is the right answer. Now let's try another example. So let's say that y is 2x plus 5, and also we have 4x plus 3y is equal to 45. Go ahead and solve the system of equations. So in this case, it's better to use another method, that is substitution. So since y is equal to 2x plus 5, we can replace the y in the second equation with 2x plus 5. So we're going to substitute it into the second equation. And so we're going to have 4x plus 3. Instead of y, it's going to be 3 times 2x plus 5, and that's equal to 45. And so now we have one equation with one variable. So now let's calculate the value of x. So let's begin by distributing the 3. And so 3 times 2x is 6x, and then 3 times 5 is 15. So now let's combine like terms. 4x plus 6x is 10x. Next, let's subtract both sides by 15. 45 minus 15 is 30. So we have 10x is equal to 30. Now let's divide both sides by 10. So x is 30 divided by 10, which is 3. Now that we have the value of x, we can calculate the value of y by plugging into the first equation. So let's replace x with y. Let's replace x with 3 rather. So it's going to be 2 times 3 plus 5. 2 times 3 is 6. 6 plus 5 is 11. And so we have the point 3 comma 11. And that's the answer. If you want to, you can plug it into the second equation to make sure your answer is correct. So let's replace x with 3 and y with 11. 4 times 3 is 12. 3 times 11 is 33. And 12 plus 33 is 45. And so this is our answer, 3 comma 11. Now the last topic that we need to review is simplifying algebraic expressions. So let's start with the basics. What is a to the third multiplied by a to the fourth? When you multiply variables together, you need to add the exponents. 3 plus 4 is 7, so you get a to the 7. Now, it's important that you understand what this means. A cubed means that you're multiplying 3a variables together. A to the fourth means that you're multiplying 4a variables together. So really, in total, you're multiplying 7a variables. The next one is division. What is a to the fifth power divided by a to the third power? When you divide, you need to subtract the exponents, the top one minus the bottom one. So 5 minus 3 is 2. Now you can also expand it. A to the fifth power means that you're multiplying 5a variables together. A cubed means that you're multiplying 3 of them together. So if you cancel 3 at a time, you'll be left with a times a, which is a squared. Let's try this one. A to the fourth divided by a to the ninth. Actually, let's say a to the 7th. So it's going to be a to the 4 minus 7, which is a to the negative 3. And whenever you have a negative exponent, to make it positive, you need to move the variable to the bottom. And so this becomes 1 over a to the 3rd. And so instead of negative 3, it's now positive 3. Now let's solve it by expanding the expression. So that's a to the 4th, and this is a to the 7th. So we can cancel 4 a's on the top and the bottom of the fraction. And so we're left with 3 a variables on the bottom. So this confirms our final answer of 1 over a cubed. Now what is b squared raised to the 3rd power? What do you do when you have an exponent raised to another exponent? In this case, you need to multiply. So that is 2 times 3, which is 6. Now if you expand it, b squared raised to the 3rd power means that you have 3 b squareds multiplied to each other. And each b squared is b times b. So you have a total of 6 b variables multiplied to each other. So it's equivalent to b to the 6. Try this one. What is 4 a to the 3rd b to the 5th power squared? How would you simplify that expression? The first thing you need to do is multiply every exponent by 2. So first is going to be 2 times 1, which is 2. So you'll have 4 squared. And then it's 2 times 3, which is 6. So a to the 6th power. And then 2 times 5, which is 10, b to the 10th power. 4 squared, that's 4 times 4, which is 16. So your answer is going to be 16, a to the 6, b to the 10. Now what is 3x squared y to the 3rd z to the 4th raised to the 0? Anything raised to the 0 power is 1. So that's a giveaway. Try this one. Negative 2 x squared y cubed raised to the 3rd power times negative 3 x to the 4th y to the 5th raised to the 2nd power. So the first thing we need to do is distribute the exponents. So we have 3 times 1, 3 times 2, 3 times 3. And also we have 3 negative signs. If you have 3 negative signs multiplied by each other, the first 2 will become positive, and then a positive times a negative will give you a negative. So whenever you have an odd number of negative signs being multiplied, the end result is a negative answer. If you have an even number of negative signs being multiplied to each other, your end result will be a positive answer. So this is going to be negative, and then 2 to the 3rd power, and then 2 times 3 is 6, so that's going to be x to the 6th power, and 3 times 3 is 9, so y to the 9th power. And all of that will be multiplied to negative 3 squared, but having 2 negatives, that's going to be positive, so it's just going to be 3 squared. And then 4 times 2 is 8, so x to the 8th power. And 5 times 2 is 10, so y to the 10th power. Now 2 to the 3rd power, 2 times 2 times 2, that's 8. And 3 squared, 3 times 3, it's 9. So what we need to do now is multiply negative 8 by 9, which is negative 72. Next, we need to multiply x to the 6 times x to the 8. So we need to add 6 plus 8, which is 14. And finally, y to the 9th times y to the 10th. So 9 plus 10 is 11. Not 11. 9 plus 10 is 19. And so the final answer is negative 72 x to the 14th power y to the 19th power. So I'm going to stop the video here. That's basically it for it. Now there's a lot of other topics in algebra that you need to review. And if you check out the link in the description section of this video, you'll find my new algebra video playlist. So feel free to take a look at that when you get a chance. For those of you who wish to subscribe, don't forget to click on the notification bell if you wish to receive updates on future videos that I'm going to post. So thanks again for watching.